Hello guys, in this video we're gonna find dy over dx of this implicit function. So how do we go about it? So of course the first step here is to indicate on both sides we're gonna derive dy over dx of ln of xy is equals to dy over dx of e to the xy. Right. Okay, so we know that the blueprint tells us that if you have y is equals to ln of u, y prime of this is equals to u prime all over u. That's the first blueprint that we know. And we also know the other blueprint on this stuff is that y is equals to e to the u, y prime of this is equals to, you're going to rewrite e to the u as it is, multiplied by u prime. So that's what we're going to use on this on this question. So on the left hand side, we're going to find dy over dx. In this case, what is this? This becomes a product rule. In order to find the derivative of the u is the product rule. So it's going to become 1 multiplied by y plus x multiplied by, what is the derivative of y? Is dy over dx all over xy equals to e to the xy multiplied by what we got there at the top, which is 1 times y plus x times dy over dx. Right, so that's that. Let's simplify at the top. What is 1 times y? It's just y plus x dy over dx as it is over xy equals 2. And then in this case, it's going to be e to the xy. And then I'm going to just, okay, let me just write it like this before I simplify it. X dy over dx. In order for me to be able to find dy over dx as it is, I need to first distribute this e to the x into the bracket. It becomes y e to the xy plus x e to the xy dy over dx. So I've just distributed this into each term inside the brackets. That's what I just did there. And then this still remains as it is, y plus x dy over dx. So what am I trying to do in this case? What I'm trying to do now, I'm trying to manipulate this stuff until I'm left with, until I can be able to put dy over anything that has dy over dx on one side. So that's what I'm trying to do. So I'll divide this by 1 and then cross multiply. So this is y plus x dy over dx equals to xy, and then I'll close the bracket, y e to the xy plus x e to the xy dy over dx. Okay, interesting. So what can I do? So this is y plus x dy over dx. And then of course this is going to become x y squared e to the xy plus x squared y e to the xy dy over dx. So what am I going to try and do in this case? I want to put this dy over the x on one side. I want to put this dy over the x on one side, right? And then I can take out the common factor. So in order for me to do that, so this is x dy over dx minus x squared y e to the x y dy over dx equals to x squared, it's equals to x y squared e to the xy minus y, right? I just took the y to the other side. So here I can take dy over dx as a common factor. Dy over dx is a common factor. I'm left with x minus x squared y e to the xy equals to x y squared e to the xy minus y. Then Therefore, dy over dx, it's equals to x y squared e to the xy minus y all over x minus x squared y e to the xy. So that's how I found my implicit differentiation here. It's very, very fundamental for you to be able to make sure that you don't make a mistake and make sure that you know what you're doing. Right. So that's very, very important here. Right. Okay. I hope this was understandable and I hope you enjoyed it. Make sure you click the like button and click the subscribe button. Make sure that you watch the next videos. Okay. Cheers, guys.